你们好，我就用英语吧，因为我们有几个国外来的人，就我用英语对不起啊。Alright, so today I'm going to talk about Dora and Dora-Drive. It's two projects that I've started with Philip Opperman. We are two Rust developers. We think that Rust is going to be very big in the future, and it's kind of the future of software engineering. And we've used Rust to build kind of a tool to make robotics simpler, and by robotic we also mean autonomous driving. So yeah, so maybe just a bit of context. In 2023, we think that open source AI is booming, but if you want to build robotics, it's kind of hard. It's still very hard. It might take months. You might be stuck at installation step, and we really want to change this. So why is it hard? It's because most people, as we said before, is using Rust and Rust 2, but Rust and Rust 2 is very bad. There's a lot of bad practice. There's a lot of tooling. There's a lot of custom messages that makes using Rust very difficult and very unpleasant. And this is very weird. Nowadays, everything is simple, and so it doesn't have to be hard, right? It doesn't have to be difficult to build robotics. We know how to make cloud, we know how to make web, and so we at Dora, we think that we can make DIY robotics fast and simple. We believe that we can make sensors and control fast and simple to use, so you just have to plug your sensors and you just have to plug your controls, and it's just going to work from the beginning. We also think that robotics is going to go towards AI, and we really want to make it simple as well. Currently, if you want to use AI with the current tooling with Rust, it's very hard. You can't use Python. You can't use a lot of Python tooling as well. And this leads me to my third point, which is that we want to limit the use of new tooling, and we want to use industry standard tooling as much as possible instead of providing new tools. So Rust, you have to learn a new logging tool that nobody uses. You have to use a new tracing tool that nobody uses. And we think that we can just use industry standard, whether it's the cloud industry standard, whether it's like web industry standard. And yeah, I'm going to go a bit deeper in details today. So maybe before, I think that we want to make it fast and simple. And what do we mean by fast? By fast, we mean that we can really simplify the way we do communication between nodes. And by that, we can think about, okay, in Python, how in Rust, there's a lot of TCP connection that is happening between different nodes. And we think that we can remove this, and we can use shared memory. And by using shared memory, we can reduce the time by 10%, by 10 times. And then we can also think a way to use zero copy between Rust and Python. And this also reduces the time spent in communication by 10 times. And so at the end, we can go up to 20 times faster than Rust 2 because we have a zero cross abstraction around two different nodes. So we can be much faster. And this is really good for us to make adoption easier because we know that if we're not more performance, like significantly more performance, people are not going to use our software. And so yeah, so how exactly do we do shared memory? So we do shared memory by having implemented our own shared memory server. So maybe some people in the industry might know Icerox. The problem with Icerox is it's written in C and C++, which means that it has a lot of build system that might not compile well on different platforms. And also it's kind of unpleasant to have Rust and C, C++ in the same program. So we wanted to simplify this. So we written our shared memory in Rust. And then we also implement zero copy. That means that we can share data between different processes without doing any copies. Being written in Rust also means that we can use our program in different OSes. So we can use it in Mac, we can use it in Windows and Linux. You can use also different programming language. If you want to use Python, we can really easily implement a client for Python, for C, C++, and Rust. And we can also do a lot of fine-tuning, a lot more fine-tuning than what you could do with a third-party provider of software. This is our first kind of advantage. The second advantage is also using a simpler message format. So we know that a lot of people are struggling with Rust because they have custom message formats that you have to use specifically, and you have to compile every time you use it. But there's this thing called Apache Arrow that makes the abstraction uniform between language and between programs. So let's say you want to use Python and Rust, you can just share the same Apache Arrow format, and the two are going to be able to communicate between the two programs. This also means that we can make zero-cost abstraction. So this is why we can do zero copy. And this is not only true for languages, it's also true for libraries. So let's say you want to send a message from Rust to NumPy, well, you will be able to do that in zero copy. And so that will be a lot more faster than what you would do if you were using a Rust message. And this is also true for NumPy, Pandas, so the data frame framework, and PyTorch, but also in OpenCV and other C++ libraries as well. And so this is our first advantage. And we really like this idea of having a universal format. And so we went further and said that maybe we can also apply it to logging and tracing and metrics, because every language has its own logging format. So if you use Python, you will have a specific logging format. If you use Rust, you will have another specific logging format. And we think that this is complicated. And we know that people want to use different language. So we use this thing called OpenTelemetry that is widely used in the industry, that it's not something that is new. And we convert every logging that we have in our Dora platform into the same OpenTelemetry format. And this provides us a way to connect to different type of backend. So let's say you want to use Datadog, you will be able to send every data that you have in Dora into Datadog, Grafana, Jaeger, Elasticsearch, and many more. And this is a common practice in cloud-native application. And so, yeah, it's nothing new. And those technologies are very mature, so it's going to really simplify the way that we can do kind of data logging for robotics. And yeah, and we really like this idea of having cloud-native kind of features. And so we wanted to make and something that is really popular in kind of cloud application is being able to do hot reloading. Meaning that if you do development, you want to be able to see the change that you do, right? So let's say you're programming a web page. You want to be able to see when you do any type of change without having to commit a message or change the, just gonna, or reset your robots. So basically what we did is that we added this hot reloading function that helps you build robot really quickly, meaning that every time you make a change in Dora, we're going to hot reload the change into our robot. So let's say we have a simple example where I'm just using a webcam to do an object detection thing, and I'm plotting it, but I see that the color is not really the right color. I don't really like yellow. I want to change it. I can change it instantly by just saving my files, and I can also add new content by just writing the content that I want. So let's say I want to add GOSIM. Or I just want to change the text that is here. Just by changing and saving, I can change this thing. But this is something that is very visual. But you can imagine that you can do the same if you have a robot. So let's say you have a robot that is going straight, and you want it to turn right. You would just have to change in the code that it has to turn right, and then the robot is going to be able to turn right. And this really makes it simple for people to code robots because they don't have to reset the robots anytime. They don't have to put it back. We know that when you're coding a robot, there's a lot of calibration that is going on. And so if you have to stop the robot, you also have to do all the calibration step again. And so yeah, so we added this hot reloading step, which is kind of common practice in web development. And this is really our philosophy. So yeah. And yeah, so this is only 3 features, but let's see if I can. Okay, and yeah, there's many more coming, like having distributed clusters. We think that it's important to be able to code on one machine and to be able to send it to a remote machine. We know that maybe you have a robot that is having its own CPU and GPU, and you're coding on your own machine. And we really want to simplify the way that we're doing distributed clusters. Maybe you want to have several robots at the same time and you want to be able to control them. So yeah, so we're working on that as well, and we're really trying to streamline the development of robotic application in the way that we believe is the simpler one. And yeah, so maybe I can give you one example of an application that we built with Dora. So one application we built is doing an autonomous driving starter kit, meaning that let's say you want to start to drive a new robot. You maybe don't want to start from scratch. Maybe you want to have some pre-built blocks that helps you kind of bootstrap your steps. You don't want to code an object detection from the start. You don't want to do lane detection from the start. So we kind of build that for you, and you just have to add them in your Dora project, and it's going to be available there. So we added some YOLO v5 detection, which is kind of industry standards. We added some lane detection. We have also object tracking, meaning that if you have several objects, you can track them through time. So, for example, in the GIF that we can see in the right, you see a car that is coming towards us, and you can basically give him an identification number, and you can just track it go as time. And so then you can do prediction, you can see where it goes. And yeah, we have many more. We have also localization based on deep learning. And so yeah, I'll let you check the Dora-Drive project. And yeah, to build this Dora-Drive project, we needed kind of a test case. We used the car simulator to try it out. And it's something that you can use with Dora-Drive. It's something that can run locally, but also on servers. And you can simulate different sensors and control, and then you can pilot your car with your Dora project and Dora-Drive, and just control the car and test Dora. It has a simple SDK. It's something that we're pushing through schools because it's something that is very easy to set up. It has almost no cost. It can run on very simple computers, so you don't have to be very performant. And then you can run from object detection to planning. So this is the line that you can see on the floor. So this is, you have several type of GPS planning and also a real life correcting planning waypoints. And yeah, so this is our first use case, but we also have a Dora rover that we're building, which is basically, we think that it's very important to also have real life use case. And so we build a small rover which is kind of which is a F110, so it's a basic, very common platform. We added an NVIDIA Orin computer and some Velodyne LiDAR, some sensors. GNSS is for GPS kind of positioning. We added some cameras to do some deep learning, object detection and tracking. And then we use some very industry standard Mavros controllers to control the different car and moving, and yeah, and it works great. The development cycle is a lot quicker than what we would have had with ROS2. We really want also to push that into school. Also, if people want to get started on weekends to start to try to build some robots, it's really a use case that we're going to build, and we're going to try to make sure that we can support, so that yeah, we think it's kind of a building blocks for robots. And then we also want to be ambitious, and we don't want to just build small robots. We're also thinking about, can we just make a car autonomous, a real car autonomous? So we bought a car, a Chinese Wuling Hongguang. It costs about 5,000, I think, euros in China, maybe twice in Europe, but at least it's a real car. And then we have kind of custom the car. We have added drive-by-wire system into the car to be able to control it with software. And then we added some sensors like 6 cameras and Chinese LiDAR and a rock-shaped computer, so that we can also reduce the cost. One of the key issues is that an NVIDIA Orin computer or whatever, like big GPU computer, might cost around 2,000 euros, which is not necessarily accessible for everyone. And so we want also, so basically we're really trying also to reduce the cost. So we built this car. We're still working on it. There's still many things that is missing, but there's like all the software is there, and so we will be able to try it out on this car, and hopefully it's working, so that we can also push that into school, people who want to get started with autonomous driving. There's many tweaks. This is a very first proof of concept, and there's many more integration to come, but the idea is really that we're trying on all levels to make our Dora-Drive autonomous driving starter kit usable everywhere. Yeah, and yeah, so basically the Dora-Drive, it gives us a lot of building blocks, and you might be interested in some building blocks, you might not be interested in others. With the Dora system, you can basically choose the one you want and the one you don't want. And we know that we hopefully want to build a community where people can share also what they've built, so that we can all contribute and we can all help each other to build this kind of robotic software, kind of like many applications like React, like when we think of Hugging Face also have this for AI. So yeah, we built this into our website, and you can search and you can add operators, is what we call node and operators. And so if you want to do planning in the future, hopefully there will be more options. If you have sensors, you will be able to find some drivers, and you wouldn't have to do all the steps yourself, and you will be able to install it really quickly, and hopefully we can also do a lot more optimization as well. We also add some documentation, so people not only have the possibility to find and search code, but they will be able to contribute and add documentation as well, and hopefully this is going to be very interactive. And we also have a Discord where people will be able to talk and share and question, and we'll be able to respond very quickly to the different need of people. So yeah, and yes, but this is really our use case, and is people using it? So for now, we're still a very small user base, so there's not that many people using it, but there's been a lot of strong interest in changing Rust because people really don't like Rust. And yeah, so we've been talking with my own school, which is Central Supélec, which is inside of the Université Paris-Saclay group, which is a French Parisian group of schools, which is very well ranked. So it's 13 or 15, I think, in the Shanghai ranking. And next year there's going to be between 3 and 8 students that is going to work on Dora as part of their student project inside of like the school year. But we've been talking with the National Taiwanese University as well, because they have a lot of project with Rust, and there's been people from the University of Cambridge that's been very interested in our project, because there's a lot of small things that can be very contributory to their PhD project. So basically they're trying to build a small motor drones, and they're trying to use it with Rust, but it has been not very good, and they've tried to build their own tooling, but it has had their own issues, and yeah, so they want to see if we could help. But yeah, there's still, and then the last one is the USTC, so it's a Chinese university that is specialized in doing research. So I think one of the speakers was actually from this school, and we've been talking because we're saying that we're really trying to build a community where everyone help each other. I think there's a lot to gain in building this open source community that doesn't really exist in Rust as well, and other alternatives. But one of the things that they told us, and you probably told them yourself, is that what about if I already have a project that uses Rust 2, can I use Dora, or should I choose to use one or the other? And the thing is, we're really trying to work on bridging the gap with legacy software, so being able to being backward compatible. Let's say you have a robot that you've built 2 years or 3 years ago, or you've been building it at school, but you know that there's a lot of drawbacks, and you know it's hard to add new features with development with Rust 2. So we built a thing called the Dora Rust 2 bridge, which is inside of our Dora project that is default in your installation, and basically we're able to auto-generate messages to Rust from Dora without any compilation. And this really gives you the fact that you don't need to install all the Rust 2 tooling to make it work on Rust 2. Because we really have very little tooling inside of Dora. So we don't want you to, because you want to bridge legacy software, that you have to install a lot of tooling. So we made it very simple. It's compiler free, and you can just use your legacy tooling without any cost. And yeah, I think that it's going to make it very easy for people that have been in the industry before to switch to Dora. So yeah, so without that, this is our roadmap. So basically we are 0.2. So we build a client for Rust, we build a client for Python and C++. We have added this arrow format that I talked about. We added this OpenTelemetry format that I talked about, and Rust 2 bridge. but many more features, but into what is. And yeah, there's many more to come. So for example, we are working on being able to do data log and replay. And by that I mean that we know that for AI, there's a big step that is called training. And to do training, you need data. And this data might not be easy to get today if you're using ROS2, because the format is not necessarily convenient. It's a very custom typed message format. And this is not really in the standards of what you would need to do AI. And so we're changing this, and we're changing this to use as much as possible Arrow, which can be used in Parquet format. And so Parquet is a very standardized format for AI and for Python and for data scientists. And so basically they will just be able to use their normal tooling as they did before without having to think, oh, I'm doing robotics. They just know how to use it already. We're also thinking about, can we make data visualization also simpler? There's plenty of tools that is very good in terms of visualization that we're maybe not using in robotics, and that could be very beneficial. And yeah, so we have a couple of ideas. We have still a couple of features coming up in 0.3. Time constraints, it's about how do we make sure that we are able to control the car in a certain time frame. And to do that, we can implement time limit for certain things. So let's say you're running a deep learning model, he's not responding in a certain time. You can bypass this in many ways. So all this about time, we think about doing it in 0.3, and then we have 0.4, which is more about how can we make fault tolerance simpler. So let's say you have a robot, there's an issue, like always. How do we make sure that we can recover from this issue? We can also think about how can we make it to the cloud. So let's say you have a robot, you want to run some deep learning model. You can put some in the cloud, and we can basically connect to the different APIs for Kubernetes and things like that, so that people don't have to learn new tools and just bring cloud native integration to Dora. And then for 0.5, we're thinking about maybe being even more ambitious and do all the things that I talked before about fleet management, about having a swarm of drones or clusters of robots, and then we can basically do a lot more things. And we know there's a lot of people thinking about V2X, right? So how do you connect a car to the different traffic light that is in your street? We know that there's people, working with different type of machines. So you might have a drone, you might have a car. How do we make it work together? And yeah, but it's actually a question that's very fundamental for robotics is maybe 5 to 10 years. So that's the things that we want to make it happen. And lastly, we're open for proposals. So if you have any idea of things that you think is cool and that you want us to implement, we'll be more than happy to consider it and try to make it happen. So we've been constantly listening for the community. So the community wanted hot reloading, so we made hot reloading possible. The community wanted backward compatibility, so we made backward compatibility possible. So yeah, we're really open. It's an open invitation for any new ideas. And by that, this is my end of my talk. Thanks for listening. And yeah, if you have any question, yeah.
对，看大家有什么 any questions。好。对，这个希望大家虽然是个开源的项目哈，希望大家多多的贡献。
So when you talk about hot reloading, is that is that fundamentally asset driven? Are you just able to twiddle values, or are you able to hot reload arbitrary Rust code?
So we are not doing the, maybe I should have precised that this is currently just for Python.
Okay.
There's a couple of ways we can do it for Rust. It's just we're just experimenting with Python yet.
Yep.
So basically we want to make it happen for Rust because it's fundamentally it will really provide a good way to make things work better with Rust. But there's a couple of small issues that we need to fix, and if we do it for Rust, what we would do is we were going to store the different states in a key value store or something like that. And then we're going to stop the Rust program, respawn the Rust program, re-inject the state, and then we're going to keep it.
Cool. I'd be happy to talk with you because we're running into some similar design goals with the hot reloading of Rust code in Bevy. So nice. I suspect there's a lot of room for collaboration there.
Oh yeah, absolutely. Philip will be thrilled because we've been talking with that for a couple of months. But yeah, I think it's very cool. on Python, it's fairly cool. I mean, it's very nice to just be able to have this really web development type of features. Yeah.
Thanks for the presentation. I think it's a really cool project. So I wonder if you have seen the like the tank, like the robotic tank from DJI. I think it's might be a good use case if we can install this Dora like inside this robotic tank. Like
the water tank, sorry.
机甲战神 from 大疆. It's a toy like where you can control a tank.
Yeah, absolutely. I mean, no, but like the thing is it a toy and is it controlled by like radio or something like that? Yeah.
Like I think it has Bluetooth.
Yeah, because actually, if it's controlled by radio is really easy to use with software. So basically, there's a lot of tooling that you can use, and you can just send radio frequencies. Radio signals, and then you can.
Robotic tank is really smart. It can like give you lots of control and give you real time.
Oh, okay.
Camera,
you already have the controls.
Yeah.
Yeah,
absolutely. If you have time, maybe I can show you in one of the DJI store.
I would love to.
Cool.
I would love to. Yeah.
So that you don't need to buy a real car, you can just put it on toys, and that's much accessible for people to use the software because it's only like 3,000 RMB.
3,000 RMB. Yeah.
It's pretty cheap.
Yeah, absolutely. Yeah. I mean, I really like to hack into things, and I think that I hope that Dora can be this tool that you can use to hack into things, right? You could just like program something, whatever you want, and yeah, just build around the. So there was a talk before about Spear, kind of a simulation for embodied AI, and I would love to hack around this as well with Dora. I think it's kind of a project that will match together very well. Yeah, thanks
you
for the question. Yeah.